Welcome to the GRE Math Subject Test video series. In this video, I'm going to grab a random problem from the Math GRE Subject Test and solve it. So in this problem, we have a pair of parametric equations, x equals cosine t, y equals sine t. T ranges from 0 to pi. And the question is, what is the length of this curve in the plane? Now, the most kind of flat-footed, so to speak, obvious way to approach this problem is to write down the arc length formula. And so just to rehearse it, right, let's actually solve it this way, not because it's the best way to solve it. We're going to solve it in a better way in a minute. But at least, let's just make sure we know how to use this, because for other more complicated problems, it could be the right way to approach a problem about arc length. So for us, let's go ahead and apply this. So we would want to calculate the integral from 0 to pi. That's the integral from a to b, square root So under the square root, the derivative of cosine, that is our x component, then squaring it, plus the derivative of sine t is our y component, squared, and we integrate this whole thing, computing these derivatives. So the derivative of cosine is negative sine, but we square it, so the negative can just disappear because of the square. And then the derivative of sine is cosine. So now we're integrating this. We need to recall is the Pythagorean identity for trig functions. So this sine squared plus cosine squared is the same thing as 1. The square root of 1 is 1. So this is the same as the integral from 0 to pi of 1 dt. And whenever you integrate a constant, then you can just multiply by the difference in the bounds. So long story short, this comes out equal to pi, and there is the answer. So the correct answer is B. Now, what's the better way to have solved this problem? It's to recognize that if we have these parametric equations, cosine and sine, with t ranging from 0 to pi, then this effectively makes a half circle, right? X equal to cosine, y equal to sine is the parameterization of a circle. You should know that. And then with t being the angle in radians sweeping from 0 to pi, then you get the top half of this circle. And from here, you can use the circumference of a circle. This is going to have unit length. So the entire circumference, if we were to draw the entire circle, would be 2 pi, and then you take half of that, so the answer is pi. So with no calculation at all, hardly, you get the same answer.